it's Bill, and today we're going to be talking about explicit and recursive functions. So, what are explicit formulas and recursive formulas? Before we answer that question, we first need to know what an arithmetic sequence is. It's a linear sequence that has a constant rate of change. So, let's start off with explicit formulas. An explicit formula is can be used to compute one term without finding all the previous terms before it. So it's helpful when you need to find what, for example, the 100th term of a sequence is. And what are recursive formulas? Recursive formulas use the same processes to get from term to term. So now, let's look at the formulas for explicit and recursive formulas. So let's start off with our explicit formula. So the explicit formula is a sub n is equal to a sub 1 plus d times n minus 1. The a sub n represents the term you're trying to solve for. A sub 1 represents the first term in your sequence. The d represents the common difference between the terms. And the n minus 1, the n is the term that you're trying to solve for. Okay, now let's go to our recursive formula. So the first thing to do is you have to define your first term in your sequence. So a sub 1 is equal to the first term. And then, if there's anything else, you define it here. So, anything else. And then, after, a sub n is equal to a sub n minus 1 plus d. So, in order to find terms, you have to solve for the previous terms. When you're using the recursive formula. So just like the explicit formula, a sub n represents the term you're trying to solve for. A sub n minus 1, the n minus 1 is the term your minus 1 plus d, which is the common difference. So these are the formulas for explicit and recursive functions. So now let's go over a few examples using explicit and recursive formulas on these arithmetic sequences. So let's start with this one, 7, 11, 15, and 19. So first, let's find our common difference, it's 4, and let's write our explicit formula. So a sub n is equal to the first term, 7, plus the common difference, which is 4, times n minus 1. So let's say we wanted to find, say, the 8th term in this sequence. So we plug in 8 as n, so a sub 8 is equal to 7 plus 4 times 8 minus 1, which is 7, which is equal to 7 plus 28, which is equal to 35. So now let's write a recursive formula for this arithmetic sequence. So a sub n is equal to, a sub 1 is equal to 7. We don't need to define anything else. So a sub n is equal to a sub n minus 1 plus the common difference, which is 4. So that is our recursive formula for this sequence. Now let's move on to this one, 20, 13, 6, and negative 1. So from here, we find that our common difference is negative 7, as we're subtracting 7 as we keep going. So a sub n is equal to the first term, 20, minus 7, times n minus 1. So let's say we also wanted to find the 8th term. Let's say we wanted to find the 5th term for this one. So a sub 5 is equal to 20 minus 7 times 5 minus 1, which is 4, which is equal to 20 minus 28, and we get negative 8. So that would be our fifth term in this sequence. So now let's find our recursive formula. So a sub 1 is equal to 20, and then a sub n is equal to a sub n minus 1 plus the first term, which is 20. So there is our recursive formula. So there you guys go. I hope you guys enjoyed the video about explicit and recursive formulas. If you guys want to suggest any topics for future videos, feel free to leave them in the comments below. Otherwise, I'll see you guys next time.